Burada olmaktan çok mutluyum. But I'm not going to do the whole talk in Turkish, thankfully. Here we go. So I've been coming to Istanbul and spending time here for many years, probably about 25 almost years now. And I've come to lots of DevOps days in different countries, but this is the first time doing DevOps days here, so I'm very kind of thankful to be invited to participate today. So a little bit about me. Here we go. So I work for Thoughtworks, which is a global consultancy. We do software development services and technology, those kind of things. Me personally, I'm focused on infrastructure automation, infrastructure as code, these types of things. So the third edition of my book with O'Reilly was published earlier this year. So basically, I spend a lot of time working with different clients, different organizations around the world to try to get the most out of the technology, right? So we adopt cloud, we adopt infrastructure automation tools, we have things like AI, all of these things, but how do we really use these effectively? Because it's not enough just to have the technology, we have to kind of learn the best ways to make use of these, and I think we're still learning. Obviously with AI, there's lots of things that we're learning. It's very, very new. We're still trying to figure out how to get the most use out of it. But even with infrastructure as code and cloud, I think most of the organizations, most of the people that I meet, we have frustrations, we have struggles. And so today I want to talk a little bit about how we, what are we doing as an infrastructure engineer or a DevOps person or something along these lines? What are we trying to do? Well, we want to enable the teams that are using our infrastructure, using our platforms, to deliver the software services to the customers for the organization by providing them with the infrastructure that they need when they need it. So really today I'm talking a bit about self-service and kind of where I think we need to move in terms of as an industry and how we use the tools to do this better. So a kind of typical path to production for a software team, some number of environments, some number of stages. It can be different for different companies. That's fine. The idea is that people are building software, they're doing validation, testing, checking for things like compliance, whatever it may be, and then we're running it, the services for users. And so these are the things that our users of our infrastructure are doing. And so we're providing, among other things, path to production infrastructure. So these test environments, staging environments, all of these sorts of things. So this is what we're providing so that they can get their work done. So typical kind of day one situation is that you have an infrastructure team that comes in. Let's say we're starting a new project, we're going to build a new system. Infrastructure team comes in and builds the environments. Right, and ideally they use infrastructure code. That makes me happy. And then once they've built the environment and the infrastructure, then they go away. Right, they're done. And so this is often the kind of concept people have, like landing zones and this kind of thing, where we come in, we lay down the infrastructure, and then we leave it to the developers now. And then the step two is the software team comes in and they start deploying their software. Maybe they make a pipeline with stages. It does the deployment into the environments. And then step three is that everybody argues about, why didn't it work? What's wrong with it? Was it a problem with the infrastructure? Was it a problem with the software? Software works on my machine, works in one environment, not another. And so this is kind of a typical sort of flow. So after all of that, then we kind of fix all those problems, and then our infrastructure is done, all right? And we're ready to kind of carry on with development, work towards releasing the first release of our software, and then fixing bugs and all these kind of things. And the idea is that the software development teams can deploy their own software as a self-service. And so this is often seen as like, this is fine. This is the kind of normal way that we do things. So day two as, okay, we're in production, we're doing things, we're deploying software changes, but then we find we need to do something, a change to the infrastructure. So it might be something like we have to add a new database or message queues, or we need to maybe make changes to the infrastructure that's deployed. We need to set up different, we need to make changes to the networking, whatever it may be. And then this typically is not necessarily self-service, all right? So this is typically where we have to bring back infrastructure people or raise a ticket or ask to put things on their backlog so that they can make the changes to the infrastructure. And so they add in the change to their infrastructure code, and they deploy that out across the environment, and then we can deploy the software to it. And again, so this, I probably don't, given where we are, we're DevOps days, we're talking about DevOps, the whole idea of having these kind of siloed work streams is, it's kind of well established that this is not the optimum way to do our work, because it has lots of delays and friction and everything. So, yeah, so the idea of having to ask somebody to come in and make changes to our infrastructure for us so that we can get stuff done, that's not really the self-service the way we want it to be. So how can we make infrastructure changes self-service as well for those software delivery teams? So maybe we can make it easier for developers to kind of change their own code, right? So we can give them tools like CDK or Pulumi or something where they can use a regular programming language that they're familiar with to work with the infrastructure, and then maybe they can just write their own infrastructure code. Typically what happens with this is that it can be fine in kind of a smaller and more straightforward system. We have one team working on their infrastructure, and they understand everything, and that understanding means it can work quite well. But it doesn't necessarily scale as we go to multiple teams. So when we have multiple teams, we have to think about, well, how do we manage then the infrastructure? And we can kind of take that model of the software developers will change their own infrastructure, will write their own infrastructure code, and we can take that, kind of multiply it. So every team is writing their own infrastructure code and managing their own infrastructure. What typically happens over time, though, is that, so the skills and effort that are required, it becomes a lot, right? So the real obstacle with developers building infrastructure for themselves and writing their own infrastructure as code isn't the language. It isn't that, YAML or Terraform code or these things are a really difficult language to learn. Most software developers can learn a new language, and a declarative language is not that difficult. The challenge is that understanding how to build, what to build, how do you set up networking routes, how do you make sure that those things are secure, how do you manage stability and all these kind of things. And again, they're easy to do at the beginning. Yeah, we can set it up, it works, it's fine. But then as we go into kind of production systems over the long term, how do we make sure that it works really effectively? And then we can handle things like outages, like what happened, was it 2 weeks ago now, the AWS outage, and then the Azure has an outage, and it's just it's normal things, right? These things happen, there are failures that happen, and so you need to build your systems in ways that are resilient to this. But that takes a lot of focus and expertise, and so for a software developer, if the software development team is having to be responsible for that, then they're not thinking as much about their software, they don't have as much time. And what happens naturally is that you get more people spending time, and we say, okay, maybe some of our software developers should focus more on the infrastructure, so other software developers can focus more on the business logic, and then you have a platform team in the end, right? You have those infrastructure specialists again. It's also kind of wasteful that you have multiple teams building things. You're not necessarily sharing and leveraging when somebody builds something really good. How do you make sure that it works across, that you use it across teams rather than have every team build their own version of the same thing? So you have 3 teams and you have 3 Kubernetes clusters, you have 3 different databases, you have 3 different ways of setting up the networking. And the quality can be inconsistent because like one team might have the person in their team who's really good at security, and so they make sure they build their systems so that they're very secure, and the other teams maybe don't have as much of that experience, and so you're not kind of getting that consistently across the teams. And then you also have to think about governance, and especially in industries like finance or healthcare, where you have regulations. You need to make sure that everything is built properly and that the auditing is in place properly and all of these things. And that's hard to do when you have a bunch of different teams all kind of doing their own thing. So, okay, maybe we should have those shared environments, right? Maybe the teams can collaborate and manage environments together. That's challenging for various reasons. You have to coordinate what different people are doing. If everybody's making changes to the infrastructure code, which makes changes to production instances of systems, then you have to think about how to coordinate that. How do you manage the complexity that starts to emerge from all of these things? And how do you put good governance into place? And so what tends to happen again is so I've seen teams that start out with this, we're not going to have separate operations teams. We're going to have the software teams own their own infrastructure and their own platforms. Over time, they tend to end up having a virtual platform team. So they might say, we don't have a platform team, but every team has the people who work on the platform, and they spend time together, and you kind of end up with a not very optimal platform team anyways. So I do want to think, I do like the idea of that collaborating on environments, but I think we need to put some things in place to make that work. So how, again, going back to the question, how can we enable self-service for these kind of more complex infrastructure tasks? So changing infrastructure, adding new infrastructure, upgrading and updates and all these kind of things. So again, the platform teams managing, a separate team managing the infrastructure for the software teams that the software teams are using. That's not really self-service. That's not the definition of self-service. Developers writing all of the low-level infrastructure code for themselves maybe it is self-service, but it's maybe too much self-service. It's too much to have to do everything for yourself as a software team. So how can we kind of make that less complicated? So I think my main kind of, point in what I'm talking about today is we need to change how we think about how infrastructure code is deployed and how infrastructure is built. And so the essence of it is we want to deploy our infrastructure code together with the applications rather than a separate stream down here. And actually, an improvement on that is to deploy infrastructure components together with the application. And so you can see I have down here like a little pipeline. So here's some infrastructure people. They're writing infrastructure as code as components, kind of as libraries. And then we have a pipeline to kind of do testing and things on it. And then that becomes available. And so the kind of model for this gets a little bit more complicated into the kind of things that we need to have in place to make this work. So the idea is that you can have engineers building a deployable infrastructure component. Those could be specialist infrastructure people. You can also have it, I'll explain in a moment, but it can also be the software developers building those where necessary. First, let me talk about, again, that pipeline. This is the kind of an important thing when you think about these components, is that you can have pipelines that do things like policy as code. They can test things or measure things like how much does it cost if somebody's writing a component to deploy a database of a certain type. Then you can kind of measure, well, how much does it cost every time we use this component? Obviously, there might be a bit of variation depending on how big is it, how much traffic, but you can start to kind of get an idea to where you can help to predict and project your costs when you're kind of using components that have been kind of designed nicely and built and tested and measured. So you can also make sure that they've been secured properly, that changes to them are create an audit trail in your logs and those kind of things. So you can build those components nicely. And then once they're up, for a component, once it's been tested in this pipeline, it can go into a repository. Right? This is just like what we do with software, with a software library. Right? We put a version number on it. We have different versions of the components. They've been tested, and they're available for use. And then what the software teams can do is they can specify which infrastructure their applications require. And the important thing here is that this is done in a way that is meaningful to the application developers, right? So they're not having to understand, how do I put together a gateway, load balancers, security groups, network, routing tables, and all those kind of things. They just know, there's a few things they might need to know. So for the people designing the components, they have to think about it like a product, like an infrastructure product. So they think a software team needs to know, they need networking to make public internet connections, come into the application. And so then we build the component to do the right things, putting in place certificates and those sorts of things. To do that correctly, or maybe they need a networking just to talk to other services inside the organization. It doesn't need to be public, and so there's different things you would do for that. And so the important thing is just that we're building these components so that they're meaningful, so that these people, the software teams, can configure it with just what makes sense to them, how does it fit with their needs. And then the software teams promote the application and the infrastructure builds across their pipeline, across the path to production, right? Again, like they would do with a software library, this becomes something like that. And then to deploy it, we can have those builds deployed into the environments, and so we can have a kind of an orchestration layer. Control plane, there's various ways of implementing this. And there's various ways of implementing that kind of the components. But one of the reasons I'm talking about this stuff is because this isn't kind of the default. There are a lot of tooling around things, particularly with Kubernetes and cloud native platforms. There are things like Crossplane. There are things like GitOps servers like Argo CD and Flux CD that you can use to implement this stuff. But the way that infrastructure is built and the way that infrastructure code and these tools doesn't make this very easy. So Terraform has modules, so you can kind of manage this with that, but then you end up having to put a lot of extra things in place or using extra tools to make this work. I'll share a little bit at the end about some information, some resources for that. But for this, an important point on this whole thing is that this gives us a lot of opportunities to put different layers of governance into place. So one of the challenges I get when I talk about this stuff, and I was talking a few months ago with folks at a bank in the UAE, and there was concern there around, well, we can't let software teams run their own infrastructure, deploy their own infrastructure, because we have to worry about the regulations and the compliance and the security and everything. But actually, this can put a lot stronger controls in place. So you can have the controls in your pipeline for your infrastructure components that make sure that these are they've been built properly and correctly, that they're not allowing anything connections through that shouldn't be allowed through, and those sorts of things. Data is stored encrypted, all that kind of thing. You can put controls around that repository of infrastructure components to say, so what's allowed in there and how can they be used, who's allowed to use the different components. Then obviously in the software pipelines, you can have your controls to make sure that everything works together with the software. And then you have this kind of layer at deployment time where you can say we're making sure that before infrastructure code or application code is deployed into our systems, that we've checked it. We can do that at kind of each stage, every environment, and this is kind of a control that's in place so that so people who work in like governance and security and compliance, they can make sure that these controls are in place and that they run all of the time. So what this can then give us is kind of a more composable approach to environments. And so when I spoke earlier around the idea that teams can manage environments together, this kind of gives some of the tools to make that a little bit more feasible, a little bit more possible. So let's say we've got our environments, we've got, testing environment, staging environment, production, and we want to add a new environment. Maybe we want to add a UAT environment. So the idea is that rather than, so in the kind of classic ways that a lot of organizations work, a lot of certainly my clients work, is that if you need a new environment, let's say we want a special load testing environment, or we want to add a UAT environment, we have to go and ask the platform team, can you do that? And it takes a long time, and it's a lot of work. Even though they're using infrastructure code, they often have to do things like we're going to make a copy or a fork of our infrastructure code for this environment and configure it a little bit differently. With this kind of workflow, what we can do instead is say we can have, like, say, a developer portal or something along those lines, which say an environment owner can configure the environment, and that environment owner could be a QA, it could be a product manager, a project manager. It doesn't have to be an infrastructure person, because what that environment owner is saying is, this is, my environment is going to be, so for UAT, it doesn't need to be accessible to the public internet, it needs to be accessible internally, and so they kind of put a setting for that. They put some settings which are going to indicate, what kind of data is there going to be in there. Is it going to be real user data, or is it going to be test user data? And that can then go into the component so that they then configure the infrastructure properly to meet those requirements without the person kind of asking for it, having to kind of build it, and without people having to come in and specifically hand build the environment for that purpose. And so they configure the environment in this portal, and then the automation just kind of creates the baseline for that environment, just kind of an empty environment. And then they also can specify, here's what applications need to be deployed in there. And so then those pipelines, it finds what's the version of the application code and the infrastructure code that we want to have deployed in this environment, and it kind of populates that. And so this can all happen without a platform team or infrastructure team necessarily needing to be directly involved in specifically, customize what's happening here. It also means we can do ephemeral environments, that is, environments that are just there when we need it and then gone when we don't need it. And just enough environments, so a small kind of environment. So as an example, let's say we have multiple software teams, maybe we're doing microservices, or maybe we're just doing kind of services, doesn't have to be completely microservice, really small, but we have a separate application component that we want to deploy and test before we do integration testing with all the other components. We want to make sure it works first. And so we can have our pipeline stage that when the pipeline stage triggers, because somebody has made a change to that software component, then a minimal environment is automatically provisioned. And just that application, so rather than having all three applications and all the infrastructure, just the one application or one service that we're testing gets deployed, whatever infrastructure it depends on gets deployed, and so we can have a much smaller environment that's in place just long enough. We run the tests. If the tests pass, we can destroy it. If the tests fail, we can stop and hold it and troubleshoot. But then once we're done with it, we're done with it. And so we don't need to keep environments running necessarily all of the time and pay the costs of running those environments all the time. So one of the things about self-service is that it doesn't necessarily mean that we don't need to talk to each other anymore, right? Because remember, this is DevOpsDays. We're talking about all of the people involved in delivering software, working together and collaborating, and that still is going to be necessary. Often we're going to need to have changes done to infrastructure components. So we might say, actually, one of the things that we're changing here, the infrastructure component doesn't support what we need it to do. And so then you do have to ask, can we make changes to that component? One of the things I wanted to say, I started to mention earlier, is that also the software teams might be able to make components that they need that just for them. So for instance, what we've seen a lot lately is where we have teams that are doing stuff around AI and data, and they maybe need some infrastructure resources that are specific to what they're doing. They need, different types of databases or different types of services deployed, or connectivity to APIs for LLM providers, those kinds of things. And so the idea here is that we now have a way, so whoever it is that's making infrastructure, that's going to build the infrastructure, has a standard way of doing it, so the software team can make their infrastructure component, and then we have the tests in place, and we have all that kind of compliance and governance going on for the infrastructure components to make sure that it's okay, it's been built correctly, and it's acceptable to put that into production, and that we have the path through the system for that to happen. And those people may need help, right? So if I'm a software team and I need a special infrastructure, type of infrastructure, we may or may not have the skills to build that infrastructure component. We may need help from another team to support us in doing that, and that's okay. We have we have ways of doing that. And then we might have to, so in production, so I'm saying that so for the team building the infrastructure component just provides the component and then they're done and the software team is deploying it, but actually we all know you get issues, you get problems, and so you need to have support. Ideally what you're doing is, what you have observability built into the platform so that to a certain extent the software team is able to troubleshoot. They've got logs, they've got dashboards, whatever, that they can use to try to understand what's going on, and maybe they can fix it by changing a configuration thing on their end. And if not, they can then go to the team that owns the infrastructure components or the teams that are running these services and ask for help with doing that. So again, it's not completely, we still need to talk to each other. And yeah, we'll have patches and updates to infrastructure code. And this is, I think, one of the things that, again, often gets forgotten about, in that when we have this kind of setup of we're going to have an infrastructure team build the infrastructure and then go away, we kind of think that once you build your infrastructure, once you have your environments, you're done. But we all know you're not, right? You're going to have to make changes. At the very least, you need to do patches and updates frequently. And so rather than saying the way that we do an update when there's a new version of, Kubernetes, new version of the database, rather than saying that those teams have to, are going to go and, okay, we're taking your environment down so that we can do the upgrade for you, you can kind of push them out like a library update, right? And so it becomes available, and when they're ready, they push their deployment into each environment, and that includes the updates and the patches, and so they're in control of when they do those updates. All right, so to kind of wrap up, like I said, we want to give these software teams and delivery teams, the people involved, the infrastructure they need when they need it. We want to allow infrastructure teams, infrastructure specialists, to be able to build reliable, configurable, deployable infrastructure components. And that we have those services available to help to kind of orchestrate and do those kind of reconciliation of the infrastructure and application code and everything into the environments. Yeah, and then have the governance embedded into the process. So I've got some links here, the QR code, and then that bottom bit.ly link there. Go to a page on my website where I talk about some of the kind of tools and services that are available that are kind of working on this space. So the kind of things that I've been saying, some of this might be familiar to you, like you might be doing things along these lines already, but for the most part, what I see is that it's not the kind of norm. It's just not kind of, the tools that are out there aren't built with this way of working by default. Most of the tools that are out there, most of the solutions where you have, like, okay, we have modules for Terraform, or we have ways of building kind of higher level constructs or components even for infrastructure. They're very much targeted at the idea of, here's a way for infrastructure engineers to build infrastructure for development teams. They're not really built with that model. There's a few exceptions. I mean, Crossplane kind of has this idea. I think it's kind of a good progress in that direction. I would say also Pulumi has got a lot of the pieces to build this kind of a workflow, because, so I mentioned when I said that having the language, a programming language, doesn't really solve the problem of making a software developer able to build their own infrastructure, when it gets really complicated. But what it does do is help you to build those components in a way that they are more configurable and more dynamic than what you can do with the declarative language. So most of my experiences and people that I've worked with who use, say, Terraform modules, struggle to make those modules really as useful as a kind of reusable thing, and people end up tending to kind of fork those module code. So this is, in kind of short, like I feel like this is the direction that we need to go, but we have a ways to go still to get there. So thank you very much. Yeah, I can take some questions.
Okay. He says, okay. So I forgot to mention, but we have this, Slido thing, so you can put your questions there if you have any questions. Oh, okay. Yes. Or you can take the microphone and ask the question yourself.
The old-fashioned way.
Yes, the best way. Any questions from the audience? Anyone? We have one question. Yeah. Okay, so I will wait. Okay. So, first question, what are your favorite IDPs and why?
So I don't work a lot with IDPs myself, actually, developer portals. I mean, I know we've done a lot with Backstage, obviously. I think the issue that people find with Backstage is that it's not a portal, it's kind of a framework for building your own portal, so it does take a lot of work to implement. I'm interested in the Pulumi IDP. My understanding of it is that it kind of focuses a lot more on the infrastructure level, so rather than necessarily all the platform services up the chain.
So the second question, in a shared infra environment case where multiple teams use the same DB, what is a good way to govern changes, pull requests? Okay.
So one thing I would tend to recommend is that teams don't share a database, particularly at the level of like maybe the schemas and so on, maybe a database where they have separate instances. So that, I mean, it's all around having those boundaries and having the kind of loose couplings. So I tend to recommend when I find, when I work with clients that have like a shared database, I tend to recommend let's look at the software architecture to kind of remove that dependency. There are often other things besides databases that are shared, and I think the important thing is just to, I think some services can be shared nicely between teams. So Kubernetes, you can generally share if the use case of how they're using it is similar. Basically, if the idea is that the software teams don't really care that somebody else is using it, right? Whereas something like, and it's been a few years since I've had to use Jenkins, but Jenkins was one of these things where when teams share it, they often have a lot of clashes because they need to use different plugins or configurations or more things are shared than should be. Whereas other services like, say, source code repository, there's very few things that one team needs to do with it that is going to conflict with another team. So I think it's that thing of just being conscious of which services teams can share nicely, and if they can't share them very nicely, try to pull those apart. And then just in terms of governance, it's like, again, putting automated checks and controls on things before they can go in so that you catch things early.
So let's take these three questions, and then we will need 5 minutes. Okay. So first, do you have any experience with OpenTofu?
So I haven't directly used OpenTofu yet. Most of my clients haven't kind of made that transition. I think because they're not in a position where the licensing restrictions necessarily affect them. But I mean, I think it's I think it's a good option for a lot of teams. I know a lot of the people who are working on it, and I think it's hopefully has a good future.
So the next one is, I understand this would be a new paradigm, but wouldn't we end up in then another higher level system that needs another higher level system to manage it?
Yes. I mean, it's always the case, right? It's always the case that we kind of build layers on top. I think the important thing, there's a couple of important things to keep that from becoming too painful, I guess. One is the simplicity, keeping it as simple as you can, and what you build in those layers. So those parts that I showed, it's a lot of moving parts. If you have like one team building software and deploying it and all of that, I wouldn't build all of those parts right away. This is what I'm talking about for when you have like, 4 or 5, 10, 20 teams. That's where you really start to the complexity. It has to go somewhere, and so you try to manage it in the system above that. Another one of the important things I would say for building these layers, in general as we do it, is making sure that you can get below into the lower layers. So each layer of abstraction, if you want to call it that, each kind of platform layer shouldn't hide what's underneath and stop people from, understanding what's happening. It should be, to my mind, abstraction should be around kind of mental context. I'm working on my application logic. I want to focus on that. I don't want to think about how do I put a networking table together. On the other hand, if I've got my application code and it's running slow, I want to be able to have diagnostic information, so observability, so I can understand why is it running slow, and then I can look into, oh, it seems to be the network. Either if I have the knowledge, I can look into that and maybe change it, or I can go to somebody who understands that and ask them for their help. So I think being able to see up and down the stack is really important.
Okay, the last question. So should the software team document infrastructure requirements for the product they're going to build, similar to a product requirements list?
Yeah, what I like is some of these systems that have essentially a specification. So rather than being like a document that is going to go on your wiki or whatever, you have a file which specifies my application needs a database. Maybe you need to specify things like what kind of information is that database going to have? Is it going to have personal information? Is it going to have really critical information like healthcare records or financial things? And so you put into the specification, the developers put into the specification what's relevant at that level for the application kind of business logic. And then that can get interpreted. So I'm really in favor of, I guess, executable specifications, I would say, things rather than documents that somebody's going to read and have to interpret.
So we have a lot of, folks from banks and, financial institutions.
Yep.
So let's take this one as the last one. Do you think it's also applicable to companies such as banks that do not use public cloud?
Absolutely. So I do have clients, and in fact, I have worked with a bank in Turkey that I won't name for confidentiality or what have you, but where I know in Turkey there's not public cloud presence, and the financial regulators, at least a couple of years ago when I was working with that client, they required it to be hosted in Turkey, and so you had to host in a data center. I have other clients, energy clients in Europe. For instance, where they have to run things in data centers. This is all applicable there. Obviously, you need to build that bottom layer of infrastructure as a service in your data center in order to make it possible to do this stuff or make it easy to do this stuff. But yeah, I think it's totally applicable, and I think it's important for anybody to be able to do this.
Kief, thank you so much.